Hey guys, I hope y'all are having a wonderful Wednesday so far. I'm recording this video right now just so you can kind of keep up with what we're doing and what we are continuing from yesterday. So yesterday we were solving equations with a variable on both sides of the equal sign. And we're going to continue on with that, and we're actually going to be looking at problems with decimals and fractions, and we're going to figure out how to solve those type of equations, again with a variable on both sides of the equal sign. Okay, so I want to go ahead and look at Schoology real fast before we actually get into that, and kind of pay attention to the week 4 Wednesday folder. So I have here the actual module that we're using for today. So it says equations with rational numbers packet. If you want, you can open that up and have that open, because that's the one I'm going to be using for this video. And of course, please make sure to work on the do now. If you want, you can pause this video, work on that do now, and then come back and play and continue on. So that's kind of what I recommend. Your do now first. And then you will have a independent practice that I will go ahead and put up here. And then of course your exit ticket. So hopefully you all can do that for me for today for your Wednesday, September 9th class. It's kind of weird to be doing these types of videos. I know we were doing them last year when we were in distant learning, when you guys were in 6th grade. I just think they're weird. It's kind of funny though. All right, so then we'll be working on the worksheet, and then we will work on some problems in the Go Math that I have linked already into Schoology. Of course, our independent practice, and then we'll end our day with the exit ticket. All right, so let me go ahead and stop this one, and let me go ahead and take you to your packet here. Okay, so make sure you also have your journals ready to go. I'm going to show you quickly. We went ahead and we're working with the last one, right? Equations with the variable on both sides. I'm going to go ahead and keep that one, and then whatever notes we have, or continue on that particular page. I really don't want to start a new topic unless I have to, but we'll just keep on with that particular page, okay? All right, so there's that. I'm gonna have this ready to go because I know there's gonna be columns that they give us like the tiniest space, and I like to work up my problems for you guys so you can see the step-by-step of it, okay? So let's pay attention to example 1. So example 1, we are going to solve an equation that is going to be really focusing on fractions. Okay, so hopefully fractions are something that you, I want to say like, but something that I guess you understand, you know how to work with them and things like that. So if not, I'm gonna try to take this as easy as I can for you and make this a flow for you a lot easier. Okay, so it says here, to solve an equation with the variable on both sides that involves fractions, start by eliminating the fractions from the equation. So this is the particular problem that they gave us. So I'm going to actually box that in. Okay, so this is the equation. So it's 7/10 n plus 3/2 equals 3/5 n plus 2. So that's our problem, right? Our equation. So step 1 says determine the least common multiple of the denominators. So hopefully you all did really well on yesterday's do now. It did consist of finding the LCM, or the least common multiple of, I think it was 2 numbers. There was some where you had to find it, and then I think some were like a true and false statement. So in case you kind of forgot how to find the LCM of numbers, let me help you out. So what we need to do is, this is really important when we are when we have fractions involved. All right. So notice our denominators for this equation are three different numbers, right? We have 10, we have 2, and we have 5. So we have three different numbers in the denominator, and we really need to find the LCM, the least common multiple, so we can turn those fractions into, we can eliminate them. That's the whole name of the game, is you want to take away the fraction, so it's a lot easier to work with the problem for that. So I'm actually going to use this part up here for your LCM. They did give us the answer is 10, right? That's great. I love that they give us the answer, but it's totally different to see the answer versus like seeing, well, how did they get 10, right? Okay, whatever, like that's great you gave me the answer, but let's figure out how we got there. All right, so this is the way I like to find my LCM, is I like to take the numbers and I like to create a little T chart on the side. So usually I only have two numbers that I'm trying to find the LCM, so I would just need one line that I'm going across one row. But since I am using three different denominators, I am going to have to write two more lines. So I'm going to write the first denominator, which was 10, the second one, which is 2, and then the third one, which is 5. Okay, so now I'm going to think of the multiples of those numbers. Okay, so I'm going to start with 10. Think of multiples. 10 times 1, 10. 10 times 2, 20. 10 times 3, 30. 10 times 4, 40. All right, we can continue on, right? Let me work with the next set. 2. 2 times 1, 2. 2 times 2, 4. 2 times 3, 6. 2 times 8, 10. 2 times 5, 10. I'm sorry, 2 times 4, 8. 2 times 5, 10. 2 times 6, 12. 14, so on and so on, right? We can keep on going. Now we have 5s. 5s are cool. 5, 10, 15, 20, 25, blah, 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 right? So now that we have our factors, right, for our different denominators, we can now look at the least common multiple, or we can find the number that is the smallest that is on each row, right? So I have 10, 20, 30, 40. Okay, here I see a 10. Awesome. Oh, here I see another 10. So I have a 10, a 10, and a 10. So that means between the numbers 10, 2, and 5, the LCM is going to be 10. Okay, so that's how we got the LCM for those three sets of numbers. So hopefully by doing that, that's going to help us find our LCM for fractions when we need to get rid of them or eliminate them. Okay, so now that we have our LCM is 10, because we found it together, now it says to multiply both sides of the equation by the LCM. So I want you to kind of look at this one here. I'm going to label this A and this B so you can really focus and see what I'm talking about. Okay, and I'm probably going to actually rewrite this just because we're going to break it down for you. So this is our LCM, so 10 and 10, and they took each side. So they took this first side, 7 tenths n plus 3 over 2, and they're going to multiply it by 10. And then the other side, 3/5 n times 2 plus 2, I'm sorry, they're going to multiply it by the LCM 10. Okay, so let me actually really look at this letter B side to kind of show you what they did just a little bit further. Okay, all right, so I'm gonna write the first part here, 7 tenths n, and I'm gonna take all of that and multiply it by our LCM, okay? Plus, and I'm gonna do the constant, 3/2 or 3 divided by 2. And I'm gonna multiply it by our LCM. There's our equals, and I'm gonna work with those, the side on the right, 3/5, and we're gonna take that term and multiply it by 10 plus 2 and multiply that by 10. So we have to take every term that we have and we have to multiply it by the LCM. Okay, so we have the LCM, 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 LCM. I should have 4 terms, right? 1, 2, 3, 4. Perfect. So I know I am on my way to figure this out. All right. So now let's look at each term individually. Okay. So the quickest way is by dividing, right? 10 divided by 10 is 1. So that actually is pretty neat because that actually cancels out, right? That gives us 1. And now we can multiply 7 times 1, which gives us 7. So we got rid of 7 tenths divided by 10 gives us 7. And we just bring down the variable, okay? Plus, here's our next one. 10 divided by 2 gives us 5. And now I'm going to multiply 3 times 5, which gives us 15. And our next term, 10 divided by 5 gives us 2. 3 times 2 is 6, but I have the variable. So this is 6n. And then I'm going to multiply 2 times 10, which gives us 20. Okay, so after we took each term, multiply it by the LCM, we got rid of fractions, right? I don't have fractions anymore. So now I have 7n plus 15 equals 6n plus 20, which is what they have here in that third proportion, which I labeled C. Okay, hopefully that you understood how we got from LCM to our fractions, using that LCM to eliminate fractions, to actually turn them into whole numbers or integers, right? It could be a negative at some point. So I think it's really neat that we can do that, because fractions, unless you really know what you're doing with fractions, fractions are probably one of the most difficult parts about math. They really, people in general, just fractions are just difficult for them. So I like that we can take the LCM and we can use it to get rid of the fraction itself and turn them into whole numbers in this case, okay? Now that we have our regular old equation, right, with a variable on the left, a variable on the right, and we need to solve for that variable, which is kind of similar to what we were doing yesterday in class. Now we can solve, right, and move things over and then get our stuff with our variable on one side and the stuff with our constants on the other, okay? So let's see, I would probably move, if I'm looking at this, I have 15 and 20, I would probably move the 15 over, right? Because 20 is more than 15. And I know that it's gonna be a positive, which is kind of what I want. So if this is adding, opposite of addition, hopefully we all know that that is subtraction, right? And what I do on one side of the equal, I have to do it to the other. Please make sure you do not add it underneath the term that has the constant, I'm sorry, that has the variable and the coefficient, just because it doesn't match up. You have to leave constants with constants, coefficients with variables together, okay? So that means I'm gonna put that guy underneath here, and that cancels out. And now I'm gonna bring this 7 in and drop them down. So I have 7n equals 6n, and then 20 minus 15 gives us a positive 5. Okay, so now we got rid of the constants, and now I'm going to worry about my coefficient with my variable, which is this one here. So since this is a positive 6, right, there's no negative, I know that I have to subtract, because opposite of a positive is a negative, or opposite of adding is subtracting. So that means I have to subtract 6 and on both sides. Why? Because 6 minus 6 gives us a 0 term, and that's what I want when I am solving. So now I have 5 all by his lonesome here equals 7n minus 6n, which just gives us n, okay? So now this is our solution. The solution for this example is n equals 5. So we went through a lot of steps, right, guys, to get to the answer, but it was they were very easy steps, okay? Knowing LCM, knowing fractions, knowing how to move constants to constants, coefficients with variables is probably one of the things that we need to kind of work on a little bit more, okay? Because I was seeing that some of us were having just a tiny bit of trouble when we did our breakout rooms yesterday. And I hope doing the step-by-step with you is really helping you remember how to solve for equations with the variables, okay? So there's that, okay? We're gonna look at that for you to have. It does break it down for you here as well. So you can go ahead and look at that and keep it with you here. You can also put it in your journal, it's up to you. All right, so now we have these your terms on this page, which is on page 304. So I'll write it up here. Okay, so please at this point, pause your video, work out these two problems, number 3 and number 4, pause them, and or work them out, pause the video, come back, and I'm gonna break it down, solve the problems for you step by step. All right, so hopefully you have answered those two problems on the your turn on example 1, which is number 3 and number 4. I actually am gonna add them to our journal just so you have those extra notes with you. So let me move this one to the side and let us look at number 3 that we did together, or you did individually. So now remember, so we're basically solving the equation, right, with fractions. So I'm gonna actually look at my denominators for any fraction that I have on both the left and the right side of the equal sign. And notice I have the number 7, which is awesome. If you have the same denominator, basically that's your LCM, right? And I'm gonna take each term and I'm gonna multiply it by that LCM. So just so we can remember, I'm gonna write it up here. Our LCM is gonna be 7 for number 3. That means I'm gonna take every term and I'm gonna multiply it by 7. Okay, so I'm gonna break it down just like we did for the example 1 itself. I'm gonna do the exact same thing. So I'm gonna take 17K. So 17K, and I'm gonna take this and I'm gonna multiply it by our LCM, which was 7, okay? Minus 6, and I'm gonna multiply it by, you guessed it, LCM, 7. Next one, 37K, and what am I gonna do? Of course, multiply it by our LCM, and our last term was 4 plus 4, and of course, you guessed it, I'm gonna take that and multiply it by our LCM. So I have 7 times 17K minus 6 times 7 equals 3/7K times 7 plus 4 times 7. All right, so now we can break this down and get rid of those fractions, right? And we can have a really good looking equation and we can solve for the variable K. So we have 7 times 1/7. So remember, basically you're gonna take this whole number and divide it by the denominator. So that's saying 7 divided by 7, that gives us 1, okay? So now I have 1 times 1K. So anything times 1 is itself. So that is just left with the letter K minus 6 times 7 is 42 equals, here we go, 7 divided by 7 gives us 1. Now I have 3k times 1. Anything times 1 is itself. So that would be 3k plus 4 times 7 is 28. So now we got rid of fractions, and now we have k minus 42 equals 3k plus 28. Awesome. I always like to add, once I'm here, I like to add a line that just lets me know what I'm going to do on one side, I do to the other, or vice versa, right? Because it has to be a balance of an equation, because then you everything gets thrown off and it's skewed. All right. So now where can I move first? Well, I kind of don't want negatives, but I'm looking here at it, and as long as I move things correctly, regardless if it's the constant first or the one with the variable, we should end up with the same answer. So I'm actually going to do this one. So if this is k, right, that basically has like an invisible one. So if you ever see a variable with just by its lonesome, always remember that there's like an invisible number 1. It's not the best one, sorry. There's like an invisible 1 in front of it, so that's just 1k. So if it's positive, if this is a positive k, opposite of something being positive is negative, so that means I'm going to subtract k from both sides, right? Because it's a balance, right? So 1k or 1 minus 1 is 0, which is definitely what I want, because, excuse me, that is getting rid of that term, right? We don't need it. Now I'm left with minus 42, but since there's nothing in front, this just turns into a negative. So now I have negative 42 equals 3k minus k. Remember, there's that invisible 1. So 3 minus 1 is 2k. Darn it, I used the wrong color. 2k plus 28. Okay. So now that I move something from the left to the right, now I need to move something from the right to the left. Okay, it has to go the other route. So now I'm going to move my constant over. So this is a plus 28. Opposite is subtracting 28 on both sides. 28 minus 28 gives us 0, which is what I want because I'm trying to move things over and group them. So I have 2k here. Now I have negative 42 minus 28. So if you remember, hopefully you remember subtracting rational numbers. Minus 42 minus 28. Remember, when you are subtracting rational numbers, please use keep, change. So I have negative 42. I change the subtraction to addition, and I change this positive 28 to a negative 28. So this is now turns into an addition of rational numbers. Negative 42 plus negative 28. Same signs, we add and keep the sign. So I'm going to add 42 plus 28. That gives me 10. This gives me 70. Same signs, add and keep. So they're both negative. So this turns into negative 70. Okay. Now I need k by himself. So since this is multiplying, opposite of multiplication is division. And I'm going to do that on, you guessed it, both sides of our little balance here. So then 2 divided by 2 gives us 1, which is what I want. And now I have k by himself. And now I'm going to take negative 70 divided by 2, or think what's half of negative 70? Negative 35. And that is our answer for number 3, k equals to negative 35. Okay, hopefully you got that one correct. If not, please make changes. And if you need a little bit more help with the fractions, let me know, and I'd be more than happy to help you out. Okay. Now let's do number 4 from that same your turn. And I'm actually going to be using this other side of our journal. All right, so this was problem number 3 that we did. Here is problem number 4. I'm actually gonna label this one, I think it's at page 8. Page 8. Okay, page 8. And this is, so we remember, this is example 1, your turn, page 304. And this is going to be for module 11.2. Okay, that's just for me to remember, for you to remember too if you need it. Okay, so here we go. This was 5/6y plus 1 equals negative 1/2 y plus 1/4. All right. Okay, so remember fractions. Either they have the same denominator, which is what we had on question number 3, which was awesome, or we got to look for our LCM because we have different denominators, which that's what it looks like in this case. So I'm just going to highlight those 3 so I know exactly what I'm going to be looking for. I'm going to go kind of up here to do our little T chart to find what's our LCM. I got 6, 2, and 4. I'm going to quickly do the factors here so I won't take up too much time. Okay, so I did some here, right? So I'm going to look and see what is the smallest number that these 3 numbers have in common. And if I look very carefully, I believe it's 12, 12, 12, and 12. Awesome, yes. So that means, and I'm going to write it here, our LCM is going to be 12. Just like we've been working with fractions, I'm going to take each term, right? And we're going to multiply them by the LCM just to eliminate, get rid of fractions. Okay, so let me start off here and I'll do our, okay, so let's take 5/6y, 5/6y, and I'm going to take that and I'm going to multiply it by our LCM, which is 12. Okay, next one, I'm going to take 1 and I'm going to multiply it by our LCM, which is 12. Okay, equals negative 1/2 y. I'm going to take that and we're going to multiply it by our LCM plus 1/4. I'm going to take that and multiply it by our LCM, which is 12. Okay, now from here we can start dividing them out to get rid of our fractions. Okay, 12 divided by 6 gives us 2. So now I'm going to take this, that's gone. 2 times 5 is 10, and there's our variable. So this becomes 10y. Okay, 12 times 1, 12. Here we go. This one. 12 divided by 2. 12 divided by 2 gives us 6. 6 times negative 1, and it's a variable. So this would be negative 6y. And then we have 12 divided by 4 gives us 3. 3 times 1 is 3. Okay, so after we found our LCM, after we multiply each term by the LCM, we eliminated fractions, and now we have 10y plus 12 equals negative 6y plus 3. If, to me, this is a whole lot easier to solve than this one up here. Is it possible to solve this one? Absolutely. I mean, yes, yes, it is. It's just like I said, fractions are a little bit tricky and you have to know exactly what you're doing with them. So I think the best way to do that is just to find the LCM and just get rid of fractions, okay? And go from there. And it's gonna get rid of them, okay? So like we've been doing, where the equal sign is, I kind of create like a wall, I guess, a little barrier. So I know what I do on one side, I'm gonna do on the other. Okay, so now I'm going to start with, where do I wanna start? Okay, let's take this one. I'm gonna take the one with the coefficient and the variable, and I'm gonna move it over. So if this is a negative, right, 6y, I need to do opposite, which is just like adding 6y on both sides. Okay, negative 6 plus 6, that cancels. Let me get rid of that altogether. And then I'm going to drop down what was here, which is 3. Okay, 10y plus 6y, that should give us a total of 16y plus 12. So I went from right to left. Now I need to move something from the left to the right. So notice what I have left here is our constant. So I need to move the one just with the constant over. So if I have plus 12. So opposite of adding 12 is going to be subtracting 12, because 12 minus 12 cancels out, which is what we need. And then I'm going to drop down what's left over, which is 16y. And now I have 3 minus 12. Hopefully we are very good on subtracting rational numbers. If not, please use keep, change, change. So keep, change, change. So now I have 3 plus negative 12. Different sign, subtract, keep the sign of the bigger number. So 12 minus 3 is 9. The bigger number is 12. Since it's a negative, this becomes a negative 9. And now I need to get rid of, I need to have the coefficient and the variable separated. Since it's multiplying, opposite of multiplying is dividing. So I'm going to take that and I'm going to divide it by 16 on both sides, which is what I just did. Let me just make this a little bit longer. All right. So now 16 divided by 16, that guy gives us 1, right? Which is what I need. Y equals, and I have negative 9/16. I'll rewrite it here. And I gotta think, can I simplify negative 9/16? I don't believe we can. By 3, by 4, by 2. No, we cannot. So this means that our solution to this equation is right here. Y equals negative 9/16. So I really hope that you all were able to answer those problems for the your turn that we have. And then let's continue on with the lesson. If not, please take them down and make the corrections. Alrighty, guys. So I'm still going to be on page 304. Now we're going to move into decimals. So I'm going to look at example 2. So if I read here, it says, solving an equation with the variable on both sides that involves decimals is similar to an equation with fractions. But instead of first multiplying both sides by the LCM, we're going to multiply by a power of 10 to eliminate the decimal. So remember that one. We're going to, instead of finding the LCM because it's a decimal, we're going to multiply by powers of 10 just to get rid of decimals. Okay. Can you work with them and not do that? Of course, yes, but this is just another way to solve it. So let me read example 2 for you. So it says here, Javier walks from his house to the zoo at a constant rate. Okay. After walking 7/100 of a mile, he meets his brother Raul, and they continue walking at the same constant rate. When they arrive at the zoo, Javier has walked for 5/10 of an hour, and Raul has walked for 2/10 of an hour. What is the rate in miles per hour at which both brothers walked to the zoo? Okay. So step one, first we're gonna have to create the equation for this particular scenario. And that equation is gonna be the distance from the brother's house to the zoo using the fact that distance equals rate times time, okay? And here it says, let R equal the brother's walking rate. So this is gonna be the variable that we're using for this particular equation. Now, like we talked about yesterday when we took down notes, for variables, X and Y are probably the most common that we use. So for this particular one, they're using the letter R for them to show us the brother's walking rate. So here we have distance to zoo, and I have 2/10 R plus 0 plus 75 hundredths. So that is going to actually represent Raul. So this is Raul's information. And distance to the zoo, when we have 5/10 R, this is, we're talking about Javier, okay? Step two, now that we created our equation, it says to multiply both sides of the equation by 10 squared, which is 100. So we're gonna take, just like we did with the LCM, we're gonna take each term and multiply it by 100. Now you're probably asking why 100s? It's just because here is the 10th place, here's the 100th place, here is the 10th place. The 100th place is the one that has the most decimals, so that's probably the best one to use to get rid of the decimal altogether. So that's probably why it's probably the best one to use. So if you have something that's like in the thousands, then multiply each term by 1,000, okay? So if we take 100 times 2/10, we get 20R. 100 times 75 hundredths, we get 75. And if we multiply 100 times 5/10 R, we get 5R. So we got rid of, we read the equation, we created the equation, and then we multiplied by 100 each term to turn that equation into something that looks a lot easier to work with, right? I think looking at something like this is a lot more appeasing to the eye than seeing decimals. I think decimals also is another one that you see it and you're kind of like, oh my God, it's a decimal, you know? So I would definitely, if you like this way, definitely try it. If you're comfortable with decimals, go ahead and leave it like that. All right, so now they're gonna use inverse operations to solve this problem right here. So the first thing they do is they move over the 20R, right? So since it's a positive, right, we have to subtract 20R from both sides. So 20 minus 20 cancels out, right? What I do on one side, I do to the other. 50R minus 20R leaves us with 30R, and they drop down the 75. So now we have 75 equals 30R. And I need to get R by itself. Since these are both, since this is multiplying, I need to now divide both sides by 30. Awesome. So 30 divided by 30 gives us R, which is what I have here. And now 75 minus 30, you would just do simple TIBO, top in, bottom out, and then you would just do division and give us the answer. So that means that the brothers had a constant rate of speed of 2.5 miles per hour, okay? So that is one way to solve for decimals with a real world situation, okay? So now you're gonna do on page, this is page 305, and I'll leave it here, page 305, so I'll go ahead, you can write it in your journal. I'm actually gonna work it out with you on your journal, and you can go ahead and work it out. Pause the video, and then we'll come back and we'll first, I'll give you the equation, and then we will solve it. So go ahead, pause it and solve it. Once you have your answer, come back and we'll check with me. All right, guys, welcome back. So let's look at this particular problem. Here we have a Logan. So he has two different aquariums. The first aquarium contains 1.3 cubic feet of water, and the other contains 1.9 cubic feet of water. The water in the larger tank weighs 37.44 pounds more than the water in the smaller aquarium. We're going to write the equation with the variable on both sides to represent the situation, and then we're going to find the weight of 1 cubic foot of water. Okay, so I think this one we kind of really need to understand how to set this one up, right? So we do know that one aquarium can have 1.3 cubic feet of water, and the other one has 1.9 cubic feet of water. Now it does tell us that the water in the larger aquarium, it weighs 37.44 pounds more than the smaller amount in the smaller aquarium. Okay, so I think for that one, you might have been tempted to write 1.9x or whatever your variable was plus 37.44. But you need to remember that the two sides need to be equal. So in fact, you should have thought, well, if I do that, you can actually subtract it from 1.9x, which would then add it to 34 to the 1.3x. So the equation itself should look like this. Okay, so if you have this, that'd be awesome. You can also have this one. You can also have the equation set up like this. For the sake of this particular problem, I like to have set it up this way, just because I've been working with equations for a while now, and I know seeing something like this is gonna end up with a lot of negatives, and I try to not have as much negatives as I can. So if you have your equation like this, awesome. You probably saw a lot of negatives at the end, but you can also rewrite it this way, and we're going to continue with this equation. So this answers that first part of going to the equation part. So this would be it. 1.9x equals 1.3x plus 37.44. So now we're going to solve for x. So if you like decimals, go ahead and you can continue on. You're just going to be dividing with decimals, and that can get a little tricky too. I'm going to get rid of them by finding the power of 10. And notice that I have the tens place, hundreds place. And since that is the one that is the largest of the powers, I'm going to take each 3 terms and multiply it by 100 so I can get rid of my decimal. So just like I did with my fraction, I'm going to take each term. So I'm going to take 1.9x and multiply by that power, 1.3x, and I'm going to multiply it by that 100 power. I'm going to take that last term, 37.44, and multiply it by the 100 power. And now I'm going to get rid of decimals so I can just have like whole numbers as much as I can. So 100 times 1.9, that means I'm going to move the decimal twice to the right, and so that becomes 190. So this is 190x equals 1.3 2 times to the right, that becomes 130x. This one 2 times So that actually becomes 3,744. Okay, so I broke down that decimals to actual whole numbers, right? Because there's no integers here or no negatives. And now we're going to solve for the problem, right? I want to know what is the weight of 1 cubic feet or 1 cubic foot of water. So this side I have coefficient with a variable, and I have coefficient variable and a constant. So I think I'm gonna have to move this one over here, right? So if this is positive, opposite of being positive is negative, or aka subtracting. So I'm gonna take that 130x and we're gonna subtract it on both sides. 130 minus 130, that cancels out, right? We get rid of that that term. And now I'm gonna drop down the 3,744 equals 190x minus 130x. I'm left with 60x. And now we are almost there. I'm gonna take that 60x, I need to get it by itself since it's multiplying, excuse me. I'm going to take opposite of multiplication, which is division. This is going to kind of cancel out. That 60 divided by 60 gives us 1, leaving us x by his lonesome. Hopefully from here, if you did not get it, please stop the video, give me T-bow, top in, bottom out, and then come back to check if you got the answer right. And hopefully you went ahead and did the division on your own, and you would have gotten 62.4. So that means in each cubic foot of water, it weighs 62.4 pounds. And I abbreviated pound by LBS, pounds. So this right here is one answer, and that one up there is another answer, right? Because we needed the equation plus the solution to that equation. Okay, so now that was the very last example that you are working on for today. I know it was a lot. I apologize. I just wanted to really go into this in depth, that you guys understand. You don't have, that you kind of understand and get it. You know, I want to make sure that you understand it and we're good to go. All right, so now what you're going to do is you're going to go into your Schoology and you are going to work on the independent practice that's there. So let me show you. So let me stop it. Okay, so now you can kind of see me. I was kind of off the camera for a while. So you have your do now. Here's your independent practice for today. I believe it's 3 questions, and then of course your exit ticket that I use for attendance. Okay, please make sure to do that for me for today. Tomorrow again we will have the same setup where it's videos and it's all this stuff. Just go ahead and try and keep track of doing your assignments. I don't want you to have to do too much at once. Again, make sure to do those exit tickets and things for your attendance, because that's what we'll be looking at. Good luck on your map testing, and I'll see you guys on the next one. Bye.